I'm not saying that. It's just tickling my throat.
The last thing I need is get the plague. Oh, me from just a different machine. Huh? I'm actually not sure, but I don't. There's a point where I just don't care. Okay, I started recording. So, a couple things. First of all, we'll be talking about the final exam on Friday. Next week's finals week. Yeah, it kind of, usually we have 2 weeks after Thanksgiving, but that kind of got away from me. So we're going to be rushing some stuff and might have to take things to a point and then say the rest is for the reader, but we'll try to get through it in any case. But one of the things we're looking at today is dealing with source code for open source projects. Specifically, this initial kind of setup video we're going to look at deals with the Bitcoin Qt project, which is actually the open source wallet for Bitcoin that actually uses a lot of the same software as the actual Bitcoin source code for running a Bitcoin server or running the blockchain server. Having said that, this is going to introduce kind of the concept of working with this stuff through a tool called Git and stuff like that. So kind of a good starting point. And then we'll talk about specifically GitHub and the Bitcoin source code from Bitcoin Master, which I already checked out, so we wouldn't have to wait for it. But in any case, it's a good starting point. But kind of what this guy talks about is the idea of open source code and some of the different licenses that open source software falls under and what that means. So it's kind of interesting. But then he also talks about the various tools for checking this stuff out. He's specifically going to be using Linux for checking stuff out, which is actually very, very close to what you'd be using for a Mac. Mac uses the Git Clone commands and things like that, which will make sense to you in a few minutes. On Windows, the tools end up being less command line. Tools end up being more GUIs. So it's actually simpler on a Windows machine where you download the clone, and it's simpler from that perspective, but probably more difficult to get dependencies and stuff for compiling. So most of these tools were built probably on Linux and are running on Linux servers. You could pull it off on the Mac because Mac is essentially a Unix operating system. So you can get most of the dependencies and compile them for the Mac operating system. Not because Mac is better, but because they stole their base from the same bases a lot of the Linux stuff was built on. Okay, so this is about 20 minutes, so we'll watch through this first, and then we'll kind of talk about the things that they discuss in there, and then go from there. The first part of this, he is talking about some things that aren't necessarily related to Bitcoin, but it's still interesting information that we may or may not have a quiz on next time.
Hey everyone. So the whole presentation that I'm giving is available on GitHub, so if you want to follow live or download it. So we'll cover why you would want to compile from source, what are some limitations about compiling, some common held beliefs that are slightly incorrect, how to do it, and then some live examples, and then Q&A if anybody has any questions.
I have that same shirt at home.
So why should anybody compile source code? If you just want to learn, play, if you want to make modifications to some product that's open source to do something else, if you want to improve and contribute, fix bugs, or add features. And a lot of people want to verify what they're running. And I'm going to focus on this for a few slides, because there are some misconceptions about what you get by compiling source yourself. So first of all, just because something's open source doesn't mean that it's necessarily that it's more secure. So there's a famous recent bug called the Hud Fleet Bug, which was actually in the open source code for more than 2 years. This is used by large institutions. It affected more than 15% of secure websites. The second limitation is that it's often very difficult to verify anything you download, even the source itself. So, for example, even if you're using SSL, HTTPS connections, if an attacker, such as a criminal or the NSA, or am I repeating myself?
Attacker.
If they have the private key of the server, they can do a man-in-the-middle attack if they have the necessary route to your client. There are other attacks. You can manipulate the certificate.
Just real quick, how many of you have heard of the man-in-the-middle attack? It's kind of an interesting thing. If you do have the key, what you can do is you can sit and listen to packets and intercept the packets before they arrive at the correct recipient and pretend like you're the recipient. So it allows you to gain access to data without actually having physical access to a machine. Kind of a famous, it's one of those security breaches in software that isn't really traceable. Because the evidence is basically that somebody else is getting your data, but it's not evident on your machine because they're not getting it from your machine. They're getting it on a per transaction basis by listening to the internet, essentially. It's kind of interesting.
And the attacker can get the certificate authority to create a new certificate that the attacker has the key for. There are some ways to get around this, but the key, the takeaway here is that I don't want anybody to think that just because they're compiling from source, they're safe from all attackers. Oh, and just one minor point there. Some people think, well, I'll just get everything through Tor or through Tails. And how do you know that what you're running, Tor, Tails, or any other product, how do you know that what you downloaded and installed was not corrupted? So it's unfortunately very difficult to verify. You need some sort of third party or other verification. This is a famous quote from Ken Thompson. He's a legend in computer science. He worked at Bell Labs. He was one of the co-creators of Unix. He's currently working at Google on the Go language. He's created UTF-8. And I'll just read this really quick. You can't trust code that you did not totally create yourself. Just a little background. What this came from a presentation that he gave on the limitations of source code. And he actually demonstrated that you can create a compiler that creates a compiler that will have a vulnerability that you will not be able to see that's there, even though you have the source code. The compiler itself is actually doing something that you can't possibly know unless you decompile the compiler. But anyway, what he says basically is that any low-level loader, such as an assembler or a loader or microcode, can have certain malware. And the last line, he says, a well-installed microcode bug will be almost impossible to detect. So this is not to dissuade anybody from compiling code, just to make you aware of the limitations and just know that this is possible. So to compile, I recommend compiling in Linux. It's, in general, there's going to be more support for it. There's going to be more questions answered on the internet. And so your problems are less likely. But certainly you can compile on Mac and Windows, whatever you like. If you would like to compile on Linux and you're running on Mac or Windows, I recommend using either VirtualBox or Windows Virtual PC or QEMU. So there are many flavors of Linux, and the instructions will vary depending on which flavor you're using. So I personally prefer Fedora, so some of these instructions will not work on Ubuntu or other flavors. These are the three packages that I'm going to talk about. Bitcoin Core, it's created by the Bitcoin Foundation, and it has the Bitcoin server that does all the, gets the blockchain. And then there's also a GUI client on top of that. Then Bitcoin Armory is a desktop Bitcoin wallet, and Bitcoin-Wallet is an Android Bitcoin wallet. Just a little background, I'm not a huge Bitcoin expert, but there are plenty here that can answer any questions. So the steps to compile, basically, the first step is review the license.
Of course.
Some licenses are restrictive in what you can do, unless you're just a pirate and you just want to do whatever. Go for it. Step two is to download the sources. And usually the sources come with instructions of how to actually compile. And then compile and install. So step one, license. Usually the license will be in a file in the root directory or on the website. And it's usually in a text file or it's on a website that post the code. If there's no license, which is unfortunately common, you have to look at, for example, if it's on GitHub, then the default license is actually very impermissive. So this is an unfortunate state of the industry right now. A couple licenses you're likely to see, MIT and BSD are very permissive. You usually just have to attribute that if you distribute that code, that where it came from. GPL, the idea there is that if you make modifications, you're supposed to share them back to the community where you got the code from. AGPL is very similar to Afro GPL. The idea is that, so with GPL, if you just download GPL source code and you just play with it locally, then as long as you don't distribute it, you don't have to make your modifications available for others. AGPL is specifically designed to deal with that so that even if you don't distribute your new code, if let's say it's on serving a website, you still need to share your modifications. So the whole idea here is to encourage people that are taking GPL source and putting it on a website and serving the product through the website to still share their modifications. Apache is very similar to MIT and BSD. It grants some patent rights. This is mostly concerned for companies, but it just explicitly grants them. Public domain, there's some questions about exactly what it means, but it's very permissive. And then there's others, of course. So to download sources, they're either zip files or tarballs. And for example, on GitHub, you can clone code, or they're simply on websites. So Bitcoin Armory has instructions on their website. And usually the zip file will have instructions in the root folder and then notes file or README file. So to actually compile source, you're taking essentially human readable text and you want to compile a binary. And these are common programs that do the compilation. So for Android, you'll use the Google SDK. For iOS, you'll use Objective-C and Xcode. For Windows, you'll usually use Visual Studio. For Linux, there's various flavors, GTK, Qt, Python. And then there's others, Maven and Swing and SWT. And then once you have an actual binary, then you just install it. Like, everybody's pretty familiar with that. So I know I ran through that pretty quick, but I will go into more detail. So for this demo, I recommend everybody just use a virtual machine. So I mentioned earlier that if you're on Windows or Mac, you can run Linux through a virtual machine. Even if you're on Linux, you can run another Linux in a virtual machine. I am using VirtualBox here just because it's pretty much supported on every platform, so just so that everybody can use it. I prefer Fedora, and I won't go through all this, but these are instructions on how to create and launch a virtual machine. So now I'm going to show some commands and code for the various steps that I covered, and I can go through any of these in the live demo, and I'll explain some of these commands. So various flavors of Linux have different ways of downloading dependencies. So source code often has dependencies of, they're not going to rebuild everything, so they're going to depend on other libraries. So for example, if you want to do encryption, you'll use OpenSSL. So there are various ways to get these dependencies.
Kind of a good example of that you guys may have run into is if you go and download or you're installing a video game on your machine and it says you need the latest DirectX drivers, that kind of stuff. So software becomes dependent on other pieces of software that it's utilizing, but it don't necessarily come distributed with it. So he's about to talk about some tools that are built into Linux, which is a kind of a far cry from the Mac side of things. There's a tool, I think Fedora uses a tool called Yum, and then which is just a wrapper for a more common one called apt-get, apt-get, which allows you to, from the command line, install a whole bunch of packages, and actually apt-get checks for dependencies. So when you grab a certain program using apt-get, it will then go and grab all the other programs that that program claims it's dependent on. Sometimes the apt-get library is, or the apt-get package isn't written correctly and it doesn't grab all dependencies. You have to go grab some specifically, but generally speaking, that's the idea. And as we get into these source code type of situations like this, I mean, when you install a video game and it asks for DirectX, a lot of times it has a redistributable DirectX with the game. You just hit yes to install and it does it. Worst case is you do a Windows update and it grabs the latest DirectX or something. But usually dependencies for Windows applications are few and far between. Whereas Linux, it's built on top of all of these old libraries, which are then built on top of newer libraries, which are then built on top of newer libraries, and then you have this thing. So you might have 30, 40, 50 dependency applications for a single package. And those dependencies, most of which are very, very tiny. You know, it's a small library that does this and another small library that does that. So it becomes very granular, where kind of the Windows world tends to be, here's a piece of software that does 50 things. And it's just there and ready to go. And this also tends to be the headache of compiling stuff from source. Historically, especially when you're compiling operating systems, which are very large, you might be sitting there, you might be compiling for 20 minutes, and after 20 minutes, it finally hits a point where it can't continue and it yells at you and says, missing dependency XYZ. And then you got to go and get that dependency and then try again. And sometimes you can just pick up where you left off. That's kind of the idea of this thing called make files, which I'll talk about here shortly. But other times you have to actually go back and do a make clean and then totally recompile again and hope you get past the last point you got stuck. And then you end up recompiling the software 10 or 15 times until you finally get it to succeed. Kind of a interesting world, I guess.
Fedora uses yum, and so these instructions show how to install the dependencies required for these Bitcoin projects. And basically, you're just specifying a list of packages to install. Pretty simple. Now, this is the most complicated of our examples, but it's also required for all the others. So I'll take some time to go through this. This is how to compile the main Bitcoin D and Bitcoin Qt source code from the Bitcoin Foundation. So I'll go through these lines. I guess I should be pointing. The first one is, the first kind of half of this is to get prerequisites and dependencies. So the Bitcoin source has certain dependencies that aren't easily installed, and you have to just get them manually. So the first command is going to just download Berkeley database that's used by the wallet. And common things that you'll see when compiling C code is you do configure, make, and make install. So configure checks your system, make sure you have every compiler and everything else. So you'll give it various options. In this case, I won't explain all the options, but if anybody has any questions, then once you've configured it, you do make. Make does the actual compiling for C programs. And then make install actually puts those binaries somewhere where, in this case, Bitcoin can use them. So in this next one, the fifth one down, we go and get SSL on Fedora. The default SSL doesn't have some of the elliptic curve technology. So
of course,
you have to download SSL and compile it to Bitcoin. So that's the next four. Again, we're doing configure, it's called config, then make and make install. These are all within the instructions files of each package. So you don't have to figure all this out on your own. And then finally down here, we're actually getting the Bitcoin core code. Git Clone will essentially download the latest source of the Bitcoin packages. And then again, we're doing configure basically with autogen. And there's various options here I can explain. But again, it's the same pattern of configure, make, and make install. And then finally, I have an example here of a Bitcoin configuration file. To run the Bitcoin server, you need a basic.
Just pause this real quick, just to kind of show you where he's at. Here is I went ahead and downloaded the Bitcoin master software earlier, and So here's when you go into that directory, you have the install file and things like that. Here's the autogen thing he was talking about. Now there's a bunch of stuff in Mac that's not supported here. That's why I wanted to show this video since I don't have a copy of Linux. But typically you would do a /configure like this. / says look in this, look in the local directory. / says look here. And it's going to run a version of this and try to configure the installer for this particular machine. It's going to figure out what your computer architecture is, what libraries are currently there, that kind of stuff. This does not do a full dependency check. This typically just says, do I have the capability of even starting to try to build this? That kind of thing. And it's going to fail on this. It doesn't do anything. It says it doesn't know about that. So it's probably going to want me to do that. It doesn't know how to deal with this type of file because Mac doesn't have that thing built in. I can download it. Not important, but that's what he's talking about here. So you would do a /configure. After you did that, you would do a make. And make actually does the compiling. So that might take, depending on the size of the project, when you compile a Java program, it compiles in a second, right? Well, so, some projects are going to take 5 minutes to compile. Others might take 5 hours. Some might even take more. I think a long time ago, I tried to build Gentoo Linux, which I don't even know if it's around anymore, Gentoo. One of the cool things about that is you could literally build the entire operating system from source, including the bootstrap. So, like I did not rely on anything installer-based to get this operating system on my computer. I did it all manually, and it took over a day to compile that source code. Which on today's computing power, I suppose, if it was the same source code, maybe would only take 2 minutes. But back then it was a day. Back then it was a day. But if you took the equivalent complexity of Linux today, it might still take a day. But in any case, you would do a make, which actually does all the compiling because there's a whole bunch of files. If I just go into the source folder here, you see all of these C++ files that are in there. So it has to go through and compile each of these, but a lot of them are dependent on other ones. So it has to compile them in certain orders and link them to each other and that kind of stuff. So it's that one make command is reading from a make file, which should be make file, which is telling you all the stuff that it needs to do for running this for compiling it. So it has a bunch of crap built into it to make sure the right things get compiled in the right order, that kind of stuff. And then finally you do a make install, and all that does is take all the binaries that it just compiled and moves them into the appropriate directories. On Unix it's usually /user/bin or /user/local/bin, something like that. That's where the binaries go, but you can really put them wherever. Okay, so let's dive back here.
Configuration file, and then you just run Bitcoin QT. So I'll show you a live version of this. So here I have Linux within Linux, and I'm going to. So this is the listing of the files that were gathered through the clone operation right here, and I've already done the compile. The compile will take about anywhere from 30 to 60 minutes when you include all the downloading of the dependencies and compiling dependencies. That's for this project. This project is huge. So the next one, Bitcoin Armory, takes 5 minutes at max. So it depends. It's proportional to how much code there is. Once it's built, when we did make install, it actually puts the Bitcoin binaries in a global directory. So I can just type Bitcoin QT. And now this is loading the Bitcoin core GUI client that was compiled in this machine. And what's great is you can obviously look at the source, you can verify it to some extent, and you can make changes. So that's what normally people do this for. I think it's going to start downloading the blockchain, so I'm just going to close it for now.
20 gigs later. Now, kind of an important thing to take away from that is he just spent an hour getting this thing to compile. Realistically, unless you've done it a bunch of times for that specific project, you're probably talking about a 4 or 5 hour endeavor to get it to all compile and be working, because you're probably going to run into dependency issues and even versioning issues. That's kind of where he was going when he's running Linux within Linux. More than likely, his virtual machine version of Linux, which he ran, he has his desktop Linux that he's using for his own crap that he has stuff installed on and things like that. He didn't want to have to modify that or possibly break things on that in order to get this thing to compile. So he had Linux running in a virtual machine, and probably had a very cut down version of the operating system running on that, with minimal extra libraries installed, so that when he needed to install dependencies, he could install the correct dependencies rather than having to worry about new dependencies conflicting with old dependencies. You know, installing SSH 3.02 instead of SSH 2.9 R3, which came with it. Are those two going to conflict with each other instead of some weird freaky deaky way? You know, maybe because of the elliptical curve thing. Of course. You know, that's the first thing I always check, to make sure there's elliptical curve support. Support, right? Exactly. So, in any case, that's why he probably did it in a virtual machine. Is A, he's going to have a better chance of success, and B, if you're going to be running this thing as a server, you probably don't want to be running a Bitcoin crypto server off of your normal desktop computer. There's bound to be problems, whether it's a bandwidth issue, an uptime issue, a library compatibility issue, or just a performance issue of using the machine in general. There's going to be problems. Although running it in a virtual machine is bound to have that same performance issue. But maybe you start off with a virtual machine until you get it set up right, then you clone it onto a hard drive and run it natively. Probably a reasonable approach.
I think it's currently 20 gigabytes or so. So, how fast your internet connection is? Yeah, I think. I mean, you probably know more about this, but I think it's.
That's actually only partially true. The anybody in here actually downloaded the entire blockchain? It really, I mean, to some extent, it'll matter how fast your internet connection is. But my experience is it only handed out at about 1 megabyte per second max. So it doesn't really matter how fast your internet is. Lately, my internet got faster, and I can pull about 14 megabytes a second, and I don't download it any quicker. Although I will say something positive happened here on the campus network today. I was putting Yosemite on one of the new Yosemite. The whole back row, the center column, but the back row of it, all those Macs now have Yosemite on it. But the first machine, I downloaded and then copied it over the network. But it downloaded the 5.6 gigabyte Yosemite install file in about Yosemite install file in about 40 seconds.
Wow.
It was cooking. I figured something was wrong, like it timed out or something. Totally no.
That was this morning?
Yeah, it was like 11:20 a.m. or so. Yeah, so I was able to get it installed on all those machines, because then I just shared it from the application folder on that machine and could grab it on the other ones, and they copied over in the local network real quick.
And that's when that's after your Google Port 80 thing and 350 wasn't working.
Yeah, that had to be a Resol thing, because I know that should work.
Linearly right now? I'm not sure. So, and we can come back to these if anybody has questions. But I'll cover all the examples.
I know I keep stopping it, but if you look at this command he has up there, the download sources, he has the Git Clone. GIT is a, actually I think I have, because I grabbed the Bitcoin thing from it. So GitHub is kind of an online repository for software. When you go into industry, you'll definitely be using GitHub. Whether you use the online version or you have your own local CVS type checkout thing, it'll be something along the lines. This is a source management tool. GitHub is actually 100% free as long as you're willing to make your project public. GitHub costs money if you want to have private projects. So you can create an account with GitHub, and you can put all your source code up there. So it's stored in the cloud, if you will. And as long as you're willing to make it public so other people can grab it, not necessarily modify it, but could take your and make changes to it for themselves, but they can't change your source code in place, you can use GitHub. But if you pay for it, then you can have your projects be private. And what's nice about these types of things, besides just having your source code backed up, I mean, if I were backing up source code to use, I use Dropbox. If it's just you working on it, or even if it's you and one other person, or GitHub and other content management source control systems shine is when you have tools like Xcode or Visual Studio all connected into them. So if you and I and Steve are all working on the same project, we can check out source code and check it back in, and this guy keeps track of all the changes. So you see over here, this is the Bitcoin project. We had 110 pull requests. Somewhere in here, there should be, here's 262 different contributions. So chances are this is from a bunch of different people. So you might have had 30 people make changes to the same exact file. So you have a whole bunch of versions of that file. Does that make sense? So at some point you need to be able, there's going to be a manager in charge of the source code, and they're going to have to choose what has been integrated into the project and what hasn't. And there's tools with this to merge changes. So if you work on one part of a file and you work on another part of the file, and I as a manager decide both of those are good, I can merge them two together to create a third file that has both of those changes in there.
Isn't the 262 contributors individual people, and then the 7,000?
Probably, yeah. These are probably the individual people who are working on the project, and then
7,460.
The number of commits, yeah. These are, but these aren't necessarily changes. But yes, you're right. So I misspoke. Commits could also be somebody checking it out and committing it back is when I'm done working, and I want to be able to saw my laptop in half and not lose code. So committing is putting everything back to the system, whether it's in a working state or not. Okay, but anyways, GitHub is a kind of the de facto tool for that. It's a good thing to get to know. I'm sure if you go into the software industry today, probably 95% of them are going to use GitHub to some capacity. I would say it's pretty rare for companies to use an internal source management tool anymore now that you have these out there. The only time you might run into it is if you're dealing with a full Microsoft shop that's been doing it for a while, then maybe they're using Microsoft Source Control or something internally. But in any case, GitHub hosts a whole bunch of projects and you can search for stuff in there. But that's kind of the deal with this tool. So he's using this tool here. I'm already in the browser. To clone the GitHub repository or the Bitcoin repository locally on his system through Git.
So the next example.
And actually the Mac has built into it Git. So that's how common this thing is the Git command. I can do a Git clone. Let's see here. Bitcoin. I think that'll do it. What's the full path to it? Doesn't matter. But you can tell it the full path to this guy and it'll clone it. Check it out.
This is Bitcoin Armory. This is a desktop wallet. It actually requires the Bitcoin D service that we just previously compiled, or if you've installed it another way. So this shows you how simple it can be. In this case, we're just cloning the Bitcoin Armory source, change directory into that folder, we'll do the compile, and then we run it through Python. And
no, I keep stopping it, but so it's talking about this wallet, this Bitcoin Armory, which is just a Bitcoin wallet, requiring the Bitcoin daemon, Bitcoin D, which this guy just talked about compiling, that took an hour or whatever. That's kind of an example of how Bitcoin is a distributed technology. So if you think about the first person who created Bitcoin, they had this Bitcoin D service working. And what is that? It's a management tool of the blockchain. But where is the blockchain? Well, you had to download in today the 20 gigabyte copy of the blockchain, but that's your own local copy of the blockchain. So remember earlier in the semester we talked about that the blockchain is duplicated a whole bunch of times. So every single person that's running the Bitcoin D service has a full copy or at least a partial copy of the blockchain. Most of the newer ones roll back the blockchain up to a point. They figure you're only going to have to go so far back. Even though the whole blockchain is out there somewhere, they don't often duplicate the entire 20 gigs. They might get the last 5 gigs, something like that. But in any case, this is the distributed nature of Bitcoin, where in the first days of Bitcoin, you probably had, let's just say, 3 computers that all had the Bitcoin daemon service running on it. And all of those guys, they were mining, writing to the blockchain and updating the central blockchain. But what does it mean to update the central blockchain? Is there actually a blockchain here in the middle? Or are they just all syncing their local blockchains with each other? So I guess what I'm asking is out there on the internet somewhere, is there the blockchain that we can go and destroy? The blockchain is as good as the number of copies that agree with each other. That makes sense? So maybe in the early days you had 3 separate computers all maintaining their own copy of the blockchain and then agreeing with each other that their copy of the blockchain matched somebody else's copy of the blockchain, matched somebody else's copy of the blockchain. Last class we started talking a little bit about the idea of the Genesis block, right? So Genesis block was the very first block that was added to the blockchain. So the blockchain is nothing unless it has the Genesis block. So all of those systems initially started, so probably the first person who started up the Bitcoin daemon had the Genesis block created, and then that synced with the next 2 that came online. Now they agree with the blockchain. So as you download that blockchain, right now it's the 20 gigabytes, essentially what you're getting is the current version of the assumed to be correct blockchain. Make sense?
Again, I'll show you what that looks like. And in fact, I think this will, if Bitcoin D is not running, it will launch it automatically. Oops. So, I mean, it's what you would expect. It's the program that we wanted to compile. And now one thing I wanted to show is one of the major reasons why people get the source code is to actually change it, compile it, to modify it the way they like it, change colors, change function. So what I recommend, learning a whole code base takes a long time, obviously depending on how large it is. So what I recommend is reverse engineering it. And there's various ways to do that, but the easiest way is to hone in on the part that you want to change by looking for it in the GUI, for example. So for example, in this case, let's say I want to change the title of the program when it's running. So what I'll do is I know what that title is as it stands, so I can just recursively search through all the code and find all instances of that. Now at that point you have to understand, in this case Python, how to code Python, or C or Java or whatever it is. So that's obviously a whole another discussion. But once you find it, you just change the code, recompile, and then rerun. It's pretty fun, I think, the first time when you make a change that is important to you and you see it actually live. And then the last example is Bitcoin Wallet. This is an Android wallet, and again, pretty simple instructions.
One thing to point out real quick is that usually when you make a modification and you recompile using the make command, it's only going to recompile the source code files that you modified. It won't recompile the whole thing. So for instance, if you make a change to the Bitcoin core to use a 1-minute block time instead of a 10-minute block time, Now that change may cross several different files. The hope is it doesn't cross too many, but let's say it crosses 5 different source code files. It's only going to recompile those 5 files, not everything. So you won't have to go through the whole 60-minute process again. Maybe it's a 1-minute process, something like that. Otherwise, it would start sucking pretty bad if every single time you want to make a small change, it's an hour to compile, which is really actually the way computer science used to be. Before you even programmed, it was wrote software and compiled it locally. You would have the punch cards. Dr. Locklear probably talked about it in your 150 class, or Professor Wall, one of the two, where you would, when you had your program written, you'd walk up to the batch processor, the person who was in charge of the batch processing machine, with a stack of cards and say, feed these through the machine and get your printout for the output, and see if it was right. Otherwise, you had to go back and repunch cards. Kind of an interesting world. That wasn't all that long ago.
The source and actually, sorry, the first step is we need to install the SDK. So the Android SDK, we'll get it from Google, and then there's an install script that downloads the various versions of the SDK. Once we have the Android SDK, then we clone the Bitcoin wallet source code, and again, well, we'll do change directory. Now we have to patch something. This is again where you need to read the instructions. It's not obvious that you would need to do this, but you'd have to patch one of the files and then compile using Maven in this case. Each compiler depends on the type of source code. And then it builds the actual APK files that you can just put right on your phone. Now they won't be signed, they won't be official, and you have to enable development mode on your phone. And this is the last slide. So when you're building, often it's just whack-a-mole with errors. So usually you will be missing some dependency. It'll say error looking for dependency X. And so you go and install dependency X. There's no magic to it. It's kind of brute force sometimes. When you'll often see this when you're running configure with C. With things like Python and Java, it's usually much easier. Things are just kind of
And just because we're almost out of time, let me insert something in here that's related to those of you who have an IT degree. One thing that you've probably seen or can at least imagine, if you're going to be maintaining a bunch of machines, servers, things like that, once you get it working, kind of get one machine set up the exact way you want, you typically would clone that in some way, mirror it. On Unix class machines, you would have some sort of configuration script. Something that after you got everything set up just right, you would duplicate all the steps that you took to install it right. So that the very next time you went to install that operating system on a new piece of hardware, or you brought in another server to clone it, or you had to redo this one, instead of having to go through all those hours of doing it, you just run your configuration script and now it just does it the right way that you did initially. You know, that's how IT here handles when they have to do lab reinstalls. They use a program, maybe Ghost or something like that, where they go in and all the machines talk to the network and say, maybe at 2 in the morning, they're going to pull the new disk image. And they'll reinstall from a source image that somebody down in IT probably put together and tested it on the same hardware that's in the labs, but they tested it on one machine and said, okay, this works. Now clone this and put it on all those computers. That makes sense? So do it once, distribute it to all these machines. Those are the types of problem solving you'll have to do. Generating user accounts and things like that, generating network shares. This is where programming starts coming into play for IT majors. So for those of you who are looking to completely avoid programming, you will have to program. Just your program will be, in some ways, more difficult. Instead of it being business application related, making things look nice for the end user, it's more of a functional side of things where things just need to work, and they're for your eyes only. So they can be ugly. They don't have to look pretty, but they still need to function. Kind of make sense? We do it on time. Let's just assume that this guy finished off making some crap up. But in any case, this gives you a pretty good introduction of working with open source code, understanding that probably step one of doing anything with an open source project, or a project from source code at least, is getting it working as is. You know, build yourself a development environment that works. Then let's start changing crap and breaking it. Okay. Well, I'm saying step one for like us. You know, if you're going to modify code, don't start off by modifying it. Start off by getting it working, then make your changes. Make sense? Step one, collect underpants. Step two, step three, profit. All right, I'll see everybody on Wednesday. Step three, profit.